Alright guys, welcome to my video on 1.4, which is extrema and average rates of change. So I'm just going to walk through the worksheet that you should have got in class, otherwise you can find it in our Google Classroom. I'll have the blank version up there for note-taking, and then our filled-in version if you want to check answers or just go through with that. So I'm going to go along kind of as slides and write in just like I would on the board, and you can follow along at whatever pace you'd like. So here we go. Okay, so the first part of this section is just identifying intervals. So we're looking at this graph that you have in your worksheet, and we want to identify intervals that are increasing, decreasing, and constant. Now we're going to use interval notation, and what might be a little bit different, as you can see over here, we are only going to use parentheses for our intervals. So we don't need brackets because those points in between aren't necessarily part of an increasing or decreasing or constant interval. They're just kind of included in both, right? Points of transition. So I'm going to mark on our graph. We're first going to do increasing over here. So I have this first red zone, which is increasing, and then this second green zone over here, which is another increasing zone, and it stops at kind of the vertex of that parabola. So just like we would do domain, we're going to use, again, parentheses. And the first thing is just from negative infinity, so that's on the graph over here where it's increasing, negative infinity to negative 2, using parentheses to set that up. And then it's just a list of intervals, so it's going to go from negative 2 to 4, and that's over in this increasing zone. That's it for that. So remember, increasing, it's like if I'm riding a bike on the function, I'm riding uphill from left to right. So it's where are the y values increasing as the x values are increasing. Decreasing is just the opposite. So we have this blue zone over here where our function's decreasing, and then this little kind of teal green zone there, and then finally that ending piece on our graph are all the decreasing pieces. And you can see I started off on the left side writing this first decreasing zone, which is that blue piece, kind of highlighted again, right? So our graph is decreasing there from negative 2, I'm taking the x values out for these, to positive 2, just like we would domain. And I'm going to keep going. We have the other little piece, which is from 4 to 5, which I highlighted there, right? That tiny, oh, that's not my highlight. That piece there, and then the last one from 7 to infinity is that last decreasing zone. Alright, so I know the graph's getting a little bit crazy, but we have all of the domain covered except for the constant piece. So that's here, what I highlighted in yellow, and that x values are from 5 to 7. So those are the constant x values, right, when the values of the y aren't changing at all. Okay, so hopefully it seems pretty straightforward. I didn't put any examples for you guys to run through in this one, and I think you can probably just go and check out the homework graphs and take it from there. But the big things to remember are we're only using parentheses, and then we're taking intervals just like we would for domain. So when we're done with all these 3 sections, those values should cover the entire domain. And I'm writing over here, these cover the entire domain. So every x value on my graph is somewhere in the increasing, decreasing, constant intervals. Alright, so again, I think pretty self-explanatory from the graph, but we should write down kind of some definitions for these increasing, decreasing, constant zones. So I'm starting off over here, and we're going to introduce maybe a new vocabulary phrase or word, and it's that IFF, which is if and only if. So a interval or some values are increasing if and only if for any 2 points on our graph. So I have there any 2 points. A positive change in the x values. So as we move to the right, as we go through the x values, results in a positive change in the y values, right? So that means our graph would be going up. We'll draw a little picture here. All right, so I have that blue piece as my x values are increasing. My y values are also increasing. And imagine you're getting on a graph, or a little turtle is getting on a graph. All right, if my graph is increasing, then that turtle's gotta work pretty hard to climb uphill. So our increasing graph. Just being silly over here. If you need more time to copy down our definition, or if you want to draw a little turtle on your graph, remember you can always pause me and rewind and go back if you need something. Alright, so let's move on to our decreasing zone. And I'm going to start the definition off the same way. So if and only if, for any 2 points on our graph, a positive change in x, so we're moving across our graph to the right, so I have here a positive change in x, results this time in a negative change in f of x, or a negative change in y. So we'll do the same thing. We'll draw a decreasing graph. So here, as my x values are moving to the right, my y values are dropping. They're getting lower. So that's decreasing. Kind of same idea for increasing. If you have a little turtle or something crawling along your graph, then he is moving downhill, right? Decreasing. So here we have my little guy again, going downhill, kind of freaked out. Alright, so we'll move on to our last piece, which is a constant portion of the graph, or a constant interval. And same idea, if and only if, for any 2 points on our graph, a positive change in x this time results in no change for y. So no change in f of x. Alright, so same idea here. We've got a graph. I missed my G over there. And just a horizontal line. So if my turtle's crawling along our graph, he's just cruising, right? He's happy. He's not going too fast downhill, not going too fast uphill. He's just having a grand old time there. Alright, so again, you guys can pause if you need more time on this page with those definitions. Hopefully nothing too new for us. And on the practice problems for homework, you guys will just be identifying pieces on the graph. Okay, so I actually jumped ahead a slide, but now I'm back. I'm going to end the video here because 8 minutes is kind of long for one watch. And if you guys want to go and try out the homework problems for identifying increasing, decreasing constant intervals, you can do that. Otherwise, check out the next video on our critical points and extrema, which is that second part of your worksheet. All right, so good luck, and definitely feel free to ask me if you have any questions.